you know what galaxies are and what are its types? If you even have these questions, then look no further. We are here to tell you all about them in this video. So stick to the end of the video to know all about them. A galaxy is a system of stars, stellar remnants, interstellar gas, dust, and dark matter bound together by gravity. The word is derived from the Greek Galaxias, literally milky, a reference to the Milky Way galaxy that contains the solar system. Galaxies, averaging an estimated 100 million stars, range in size from dwarfs with less than 100 million stars to the largest galaxies known, supergiants with 100 trillion stars, each orbiting its galaxy center of mass. Most of the mass in a typical galaxy is in form of dark matter, with only a few % of that mass visible in the form of stars and nebulae. Supermassive black holes are a common feature at the centers of galaxies. Types of galaxies. Almost all current systems of galaxy classification are outgrowths of the initial scheme proposed by the American astronomer Edwin Hubble in 1926. In Hubble's scheme, which is based on the optical appearance of galaxy images on photographic plates, galaxies are divided into 3 general classes: ellipticals, spirals, and irregulars. Hubble subdivided these 3 classes into finer groups. In the Hubble Atlas of Galaxies 1961, the American astronomer Alan R. Sandage drew on Hubble's notes and his own research on galaxy morphology to revise the Hubble classification scheme. Some of the features of this revised scheme are subject to argument because of the findings of very recent research, but its general features, especially the coding of types, remain viable. A description of the classes as defined by Sandage is given here, along with observations concerning needed refinements of some of the details. Elliptical galaxies. These systems exhibit certain characteristic properties. They have complete rotational symmetry, that is, they are figures of revolution with 2 equal principal axes. They have a third smaller axis, which is the presumed axis of rotation. The surface brightness of ellipticals at optical wavelengths decreases monotonically, outward from a maximum value at the center. Spiral galaxies. Spirals are characterized by circular symmetry, a bright nucleus surrounded by a thin outer disk, and a superimposed spiral structure. They're divided into parallel classes: normal spirals and barred spirals. The normal spirals have arms that emanate from the nucleus, while barred spirals have a bright linear feature called a bar that straddles the nucleus, with the arms unwinding from the ends of the bar. The nucleus of a spiral galaxy is a sharp peaked area of smooth texture which can be quite small, or in some cases can make up the bulk of the galaxy. Both the arms and the disk of a spiral system are blue in color, whereas its central areas are red, like an elliptical galaxy. The normal spirals are designated S and the barred varieties SB. Each of these classes is subclassified into 3 types according to the size of the nucleus and the degree to which the spiral arms are coiled. The 3 types are denoted with the lowercase letters A, B, and C. There also exist galaxies that are intermediate between ellipticals and spirals. Such systems have the disk-shaped characteristic of the latter, but no spiral arms. These intermediate forms bear the designation S0. S0 galaxies. These systems exhibit some of the properties of both the ellipticals and the spirals and seem to be a bridge between these 2 more common galaxy types. Hubble introduced the S0 class long after his original classification scheme had been universally adopted, largely because he noticed the dearth of highly flattened objects that otherwise had the properties of elliptical galaxies. Sandage's elaboration of the S0 class yielded the characteristics described here. S0 galaxies have a bright nucleus that's surrounded by a smooth, featureless bulge and a faint outer envelope. They're thin. Statistical studies of the ratio of the apparent axis seen projected onto the sky indicate that they have intrinsic ratios of minor to major axis in the range of 0.1 to 0.3. Their structure doesn't generally follow the luminosity law of elliptical galaxies, but has a form more like that of spiral galaxies. Some S0 systems have a hint of structure in the envelope, either faintly discernible arm-like discontinuities or narrow absorption lanes produced by interstellar dust. Several S0 galaxies are otherwise peculiar, and it's difficult to classify them with certainty. They can be thought of as peculiar irregular galaxies. that is, IRR2 galaxies, or simply as some of the 1 or 2% of galaxies that don't fit easily into the Hubble scheme. Among these are such galaxies as NGC 4753, which has irregular dust lanes across its image, and NGC 128, which has a double, almost rectangular bulge around a central nucleus. Another type of peculiar S0 is found in NGC 2685. This nebula in the constellation Ursa Major has an apparent edge-on disk galaxy at its center, with surrounding hoops of gas, dust, and stars arranged in a plane that is at right angles to the apparent plane of the central object. SA galaxies. These normal spirals have narrow, tightly wound arms, which usually are visible because of the presence of interstellar dust and, in many cases, bright stars. Most of them have a large amorphous bulge in the center, but there are some that violate this criterion, having a small nucleus around which is an arranged amorphous disk with superimposed faint arms. NGC 1302 is an example of the normal type of SA galaxy, while NGC 4866 is representative of one with a small nucleus and arms consisting of thin dust lanes on a smooth disk. SB galaxies. This intermediate type of spiral typically has a medium-sized nucleus. Its arms are more widely spread than those of the SA variety and appear less smooth. They contain stars, star clouds, and interstellar gas and dust. SB galaxies show wide dispersions in details in terms of their shape. Hubble and Sandage observed, for example, that in certain SB galaxies, the arms emerge at the nucleus, which is often quite small. Other members of the subclass have arms that begin tangent to a bright, nearly circular ring, while still others reveal a small, bright spiral pattern inset into the nuclear budge. In any of these cases, the spiral arms may be set at different pitch angles. A pitch angle is defined as the angle between an arm and a center centered on the nucleus and intersecting the arm. Hubble and Sandage noted further deviations from the standard shape established for SB galaxies. That's it for the video. If you enjoyed it, kindly like the video and subscribe to our channel.